This is Keeper 2.2, Algebraic Limits. The limit of a function exists if the limit from the left exists, the limit from the right exists, and the limit from the left side is equal to the limit from the right side. Also, it's important to note that this function f of x does not have to exist at that point, a of f of a, in order for the limit to exist. So what this means is you could have a limit at a point, and we're talking about x approaching a, as long as it exists from the left side, the right side, the limits of the left and the right equal each other, but it doesn't have to exist at that point. Finding limits algebraically. We're given three limits, all as x approaches a, but on three different functions. So you're given that the limit of f of x as x approaches a is -3. The limit of function g of x as x approaches a is 0. And the limit of function h of x as x approaches a is 8. So first of all, we want to find the limit of f of x plus h of x as x is approaching a. Let me get my pen. So I'm going to rewrite this. And the limit is x approaches a of f of x plus the limit is x approaches a of h of x. It's really important to write this the way I have. You can't just skip straight to, I'm going to plug in these numbers. So now I've got the limit of f of x as x approaches a, and that's -3, plus, and I'm going to look for the limit of h of x when x is approaching a, and that's 8. So -3 plus 8 is 5. Remember, do not circle your answers. It's really important when you get to the AP test. So number 2, we want the limit of f of x squared as x is approaching a. Again, I'm going to rewrite this because I need to be squaring the limit of x approaching a of f of x, just like it looks in the given section. So rewrite this. Limit x approaches a of f of x squared. Now, the limit of f of x as x approaches a is -3. -3 squared is 9. And one more example. 3, you want the limit of the cube root of h of x as x is approaching a. So I'm going to start by rewriting it because it's the cube root of this whole limit that we're trying to find. So the cube root of the limit as x approaches a of h of x. Look at your given section. The limit of h of x as x approaches a is 8. The cube root of 8 is 2. Number 4, evaluate the limit of the function 5x squared minus 6 as x approaches 3. Well, you know that 5x squared minus 6 is a quadratic function, and it's continuous. So if I had this graph to look at, I could just look at the x value 3 and see where it exists, because it's going to have the same limit from the left and the right as the point where it exists. So you always want to try to use direct substitution to find that limit, that y value. So for this one, I can just simply plug in the x value that I'm approaching, which is 3, into the function. So So you have 3 squared, which is 9. 5 times 9 is 45. 45 minus 6 is 39. So that's the limit. If you were able to see this graph, there's a point on 5x squared minus 6 at 339, which is approaching from both sides. So take a look at number 5. You have the limit of a rational function. You know, rational functions have vertical asymptotes. So those are places where you may not be able to directly substitute. But it could be at x value anywhere else on this rational function. So I'd always look at the function and see if I could use direct substitution, which means to just find that y value by plugging in the x that you're approaching. So here we're approaching -1. Now I'm going to plug in -1. -1 minus 2 is -3. Simplify the denominator. What do we have? We have 1 minus 4. That's -3. -3 minus -3 is -6. And that simplifies to just be 1/2. So that's an actual point on this function. -1, 1/2. It doesn't have to be a point for the limit to exist, but if it does exist there, then we're able to directly substitute that x value into the function. Take a look at number 6. We want the limit of x squared minus 16 over x minus 4 as x approaches 4. Well, it's another rational function. Rational functions, you could have places in your graph that have a hole. You could have a vertical asymptote. Several different issues could arise where you would not be able to just directly substitute to get the limit. That happens with this problem. If I start by using direct substitution like I did on the other problems, I have 4 squared minus 16 over 4 minus 4. That's 0 over 0. That means that this graph doesn't exist at 4, but that doesn't mean that there's not a limit as x approaches 4. So when this happens, when you get 0 over 0 with direct substitution, there's more that you need to do to this function to simplify or rewrite so that you can evaluate the limit. So if you look at this one, we can factor that numerator. Now it's really important to keep writing the limit as x approaches 4 until you substitute. So I'm going to factor the numerator x plus 4, x minus 4 over x minus 4. Okay, I can simplify that. Still have the limit as x approaching 4. But x minus 4 in the numerator and denominator will cancel, and now it simplifies to be x plus 4. And just as a reminder, when you have a factor that cancels in the numerator and denominator, a hole is created. So if we were able to look at this graph, there's a hole in the graph at x equals 4, which is why we couldn't directly substitute. That's why we got 0 over 0. But now I've simplified it, and I can substitute this 4. So 4 plus 4 equals 8. So the limit as x approaches 4 is 8. Number 7. I would always take try to glance at it and before starting to factor and see, can I just plug in this x value? So I have x approaching 0. So look to see if I plug 0 in the numerator, am I going to get 0? And if I plug 0 in the denominator, am I going to get 0? Because that tells me like I need to do more work like I did here in blue. But for this one, I can use direct substitution again. When you are substituting in the number for x, do not write limit x approaching 0 anymore because you are substituting into the problem. if you are simplifying the problem, you still write the limit as x approaches 0. Okay, so plug in 12 times 0 plus 3. The numerator is going to simplify to be -9, and the denominator simplifies to be 3. -9 divided by 3 is -3. When possible, try to write your answers or your work in like one vertical line instead of all over the place. So we need to be able to follow your work. The AP reader has to be able to follow your work for you to get credit. Number 8, we want to evaluate the limit of x squared minus 4x plus 4 over x squared plus x minus 6 as your x is approaching 2. Remember, we're going to keep writing limit as x approaches 2 until we are ready to directly substitute. Factor your numerator and factor your denominator. You get x plus 3 times x minus 2. Now I can cancel the common factor of x minus 2. There's a hole in the graph at x equals 2, which is why we couldn't use direct substitution to start with. Write what is remaining. So the limit is x approaches 2 of x minus 2 over x plus 3. Now I'm able to directly substitute 2 into x and find the limit without getting the 0 over 0. 2 minus 2 over 2 plus 3, that's 0 over 5, which equals 0. Now that means that this graph had a hole in the graph at the point 2, 0. The function is approaching 0 from the left and the right side of x equals 2. Number 9, this is similar, except for we're going to use sum of cubes to factor. Limit as x approaches -2. You should all be able to factor really, really well. Okay, so the sum and difference of cubes formula, you take the cube root of the first term, which is x. You take the cube root of the second term, which the cube root of 8 is 2. And then your formula is AB, so you get x plus 2, a squared, AB, b squared. So that's where the x squared, the 2x, and the 4 come from. And it's always the opposite sign in the trinomial. You probably learned SOAP. Same sign as the problem, opposite sign always is plus. Over x plus 2. So I've got that factored. X plus 2 in the numerator and the denominator cancel. And now the limit as x approaches -2 of x squared minus 2x plus 4. We're able to substitute -2 in for x. -2 squared minus 2 times -2 plus 4. 4 plus 4 plus 4 is 12. Number 10. The limit of x squared minus x minus 12 over x plus 3 as x is approaching -3. You should be able to do this one by now. It's really similar to what we've been doing. I'm just going to factor this numerator. Rewriting that, so that factors to be x minus 4 times x plus 3 over x plus 3. X plus 3's will cancel. Now the limit is x approaches -3 of x minus 4, and I can directly substitute that -3 in for x. -3 minus 4 is -7. Okay, so now we're going to get into some different approaches when you're not able to directly substitute. Like on number 11, we're talking about x approaching 9. If I just plugged in a 9, I would have 9 minus 9 is 0. 3 minus the square root of 9 is 0. So I got 0 over 0 again. So it means there's something else I have to do to this problem. You learned how to rationalize denominators, and you could do that, but we want you to use a factoring approach when you can. We will rationalize some numerators, I think even in the next problem. But if you take a look at this problem and you think about difference of squares, 9 minus x can be factored. 9 is a perfect square. If I take the square root of it, it's 3. And then x, you wouldn't normally take the square root of that like in Algebra 2, but you can take the square root of x and you get square root of x. And that will help me simplify with the denominator. So we're going to use the difference of squares to factor the numerator. So that is a plus b, a minus b when you take the square root of the first and second term. So the numerator will factor to be 3 plus the square root of x times 3 minus the square root of x. Multiply that together, you get 9 minus x over 3 minus square root of x. So you can see it's still similar to what we've been doing, except for it's not as obvious as something to factor. But always take a look at your numerator and denominator and see if you could use difference of squares or some or difference of cubes to help you simplify. I'm left with 3 plus the square root of x after simplifying that function. Directly substitute. 3 plus the square root of 9 is 3 plus 3, which equals 6. Number 12, the limit of x minus 8 over the cube root of x minus 2 as x approaches negative 8. Very similar to number 11, except for we can't use the difference of squares. But if you take a look at the denominator, you see that there's a cube root of x, and you also notice that 2 is the cube root of 8, then we can use the difference of cubes formula to factor that numerator. Limit as x approaches 8. You write that down. Okay, so the cube formula for factoring. You're going to take the cube root of your first term. The cube root of x is cube root of x. Take the cube root of the last term. So the cube root of 8 is 2. Now, for the trinomial, we call the cube root of x a, and we call this 2b. And so for the trinomial, this is a squared. So the cube root of x squared. And for our middle term, it's a times b. So cube root of x times 2 is 2 times the cube root of x. And b squared. 2 squared is 4. SOAP, the word SOAP helps you to remember the signs. So the same sign as the problem, and we're talking about the numerator, so minus. Opposite sign would be a plus, and always a plus at the end. Over the cube root of x minus 2. All right, that factor will cancel. The limit as x approaches 8 of the cube root of x squared plus 2 cube root of x plus 4. Okay, now substitute your 8 in for the x. So the cube root of 8 squared plus 2 times the cube root of 8 plus 4. The cube root of 8 is 2. 2 squared is 4. Cube root of 8 is 2 times 2 is 4 plus 4. So that equals 12. Okay, take a look at number 13. This one looks different from the other functions that we have been evaluating limits. You have the limit of the square root of 2 minus x minus the square root of 2 over x as x approaches 0. If we just directly plugged in the 0 for x, you get the square root of 2 minus square root of 2, which is 0, over 0. So we've got to do something, and we can't factor it. In Algebra 2, you rationalize denominators by multiplying by the conjugate whenever you are told that you're not allowed to leave a radical in the denominator. Well, we are going to be rationalizing this numerator so that we can simplify this problem, because we need to get this x out of the denominator for one thing. The conjugate of the numerator, write out the problem again. Don't just add on to the problem. So that's what we have to start with. And I'm going to multiply by this conjugate. Oh, sorry. So the conjugate is square root of 2 minus x plus the square root of 2. So whatever you multiply to the numerator, you're going to do that same thing to the denominator. Okay, so now I'm going to actually multiply that numerator. When you multiply the conjugates, you end up getting like a squared minus the b squared. The outside and the inside will cancel. The square root of 2 minus x times the square root of 2 minus x is just 2 minus x. And the square root of 2 minus x plus the square root of, or times positive square root of 2 is the opposite of the square root of 2 times the square root of 2 minus x. So those end up canceling each other out. And then negative square root of 2 times positive square root of 2 is just negative 2. Over x times the square root, 2 minus x, plus the square root of 2. Okay, so continue to simplify. The numerator, 2 minus 2 is 0. So then I have negative x left in the numerator. Well, negative x over x is going to simplify. So then I have negative 1 over the square root of 2 minus x plus the square root of 2. So the numerator simplified to just be negative x, and the negative x over positive x simplified to just be a negative 1 in the numerator. Okay, so now look at this. If I substitute the 0 in for x, I'm no longer going to have a 0 in the denominator or a 0 in the numerator. So we multiplied by the conjugate of the numerator. We rationalized the numerator in order to simplify this problem. So I'm just going to go over to the side because I'm running out of room behind it. And I have negative 1 still in the numerator. And if you substitute the 0 into the denominator for x, you get the square root of 2 plus the square root of 2. And that equals negative 1 over 2 square root of 2. You do not have to rationalize this denominator. That's a perfectly fine answer. Okay, number 14. We're going to evaluate the limit of this complex fraction as x approaches 3. So I'm going to start by simplifying that numerator, get a common denominator. As soon as I get my pen to work. Limit as x approaches 3. So the common denominator in the numerator is going to be 3x. So I'm going to multiply the first fraction by 3. 1 times 3 is 3. Minus, and I had to multiply the first denominator by x. So 1 times x is x over x minus 3. we still need to do some simplifying and rearranging. So if I put that numerator together as one fraction, that's 3 minus x over 3x. I'm going to rewrite that and move my x to the front and factor out a -1. Because if I look at my denominator, I have a positive x minus 3. And so if I can factor a -1 out of that numerator, then I'll be able to cancel a common factor. So rewriting the numerator, I have -1 times x minus 3 over 3x. Again, I rearrange the 3 minus x into negative x plus 3, factored out a -1. That's over x minus 3. Limit as x approaches 3. Let's look at this. So this is division. Fractions are division. I have -1 over x minus 3, or -1 times x minus 3 over 3x divided by x minus 3, which dividing by x minus 3 is the same as times 1 over x minus 3. So now we can see that the x minus 3's will cancel. I can write this as one fraction. The limit is x approaches 3, and x minus 3 and x minus 3 will cancel. So -1 over 3x. All of that simplifying still has the limit as x approaches 3 out front of it. And now I can evaluate. -1 over 3 times 3 equals -1/9. Number 15, we have 2 more examples, or 16 total. Number 15 is actually similar to number 14 that we just did. If you notice in the numerator, 3 plus h is raised to a -1. So I'm going to rewrite that. Notice it's the limit as h approaches 0, not x approaches 0. There could be any variable. It's the variable that's within the function. So if you look at this problem, it doesn't say 3 plus x to the -1. It says 3 plus h to the -1. So we're talking about that h approaching a certain value. Rewrite 3 plus h to the -1 as 1 over 3 plus h minus 3 to the -1 is 1/3. So again, you have a complex fraction. We're going to follow the same steps. So the first thing that I'm going to do is subtract that numerator so that I have one fraction. So I need to get a common denominator. The common denominator is going to be 3 times 3 plus h. Okay, so 1 times 3, that's 3 minus, and then you have 3 plus h in that second numerator. Remember, it's minus 3 and it's minus h when we go to simplify this in the next step. All over h. Still simplifying the numerator. Limit as h approaches 0. Like I said, I have 3 minus 3. That's 0. And then the negative is also distributed to the h in the numerator. So it's negative h over 3 times 3 plus h divided by h. Dividing by h is the same as times 1 over h. Limit is h approaches 0. I can simplify negative h and positive h. That's -1 in the numerator. 3 times 3 plus h in the denominator. And now we can evaluate for the limit. Okay, so that's going to equal -1 over 3 times 3 plus 0, which equals -1/9. This is our last example for today in your keeper. Number 16, limit of 3x minus 2 squared minus x plus 2 squared over x minus 2 as x approaches 2. Now, you do not want to write out 3x minus 2 times 3x minus 2 and multiply that together, and the same with the x plus 2 squared. That's not going to help you because you'll still plug in the 2 and get 0 over 0. So you got to find a way to simplify this problem. Believe it or not, this is factoring. And it's a difference of 2 squares. Like you've got first term squared minus second term squared. Limit as x approaches 2. Okay, so take the square root and you get 3x minus 2. I'm going to use another set of parentheses plus the square root of the second term, which is x plus 2. And 3x minus 2 minus x plus 2. So the format for difference of squares is a squared minus b squared. And it factors to be a plus b, a minus b, which is exactly what happened here. All over x minus 2. So we're going to simplify this numerator now. Within that first thing, the a plus b, combine like terms. And I don't really need this parentheses because that's just 4x, but I'll just keep it there. And then combine like terms in your second factor. And 3x minus x is 2x. Negative 2 minus 2 is negative 4 over x minus 2. So I don't have anything that I can cancel yet, any common factors. But I can factor out a 2 from the 2x minus 4. If I factor out the 2, then it's 2 times 4x, which is 8x times x minus 2 over x minus 2. And then the limit as x approaches 2 of 8x, we can evaluate. 8 times 2 equals 16. And that's your last example for Keeper 2.2.